So, um, again, just because this is a little bit of a, especially for people who aren't like so tech savvy or whatever, a little different, whatever. So move at least 3 guide points below to complete the graph. Y equals 2 over x plus 6, x minus 6. This is a reciprocal function. Gary, you can watch this. Oh, I should have said your name. Oh well. You can watch this if you want because you can see this. So you're just moving it's x minus 6, so there's a vertical asymptote at x equals 6. So this blue dot represents the blue asymptote. And you just move it. And then if it was negative, you would reflect it. That should be it. But let's see. All right. Oh, it's a stretch. It's got a little stretch. Well, let's see. Let's try it. Oops. Adding, subtracting. Did I move it to, no, I moved it to 6. Scalar, so how do I stretch this thing? Let's see. Let's do another one. So we moved it, and then you stretch the dot by 2. All right, cool, so let's do another one. The last one that I did, I didn't have to stretch it all. Okay, cool. So great. So this one has, the vertical asymptote is right here at the opposite, -6. So I move this to -6 first of all. And then I got to stretch that. It's got the top number is the stretch. So I got to stretch this by 7. So this is at 1 right now. I just stretch it up to 7. And that's it. And if it was, again, if it was negative, I would reflect it. So the answer, and that's it. So that's the first one. It's a reciprocal function. Then comes a rational function, a little bit harder. Not much, but you got to put 4 things on there. It's going to require a little work. The first 2 are not hard. So we have a horizontal, a vertical asymptote is always at the bottom of the denominator. So x equals 3. So you have to choose to put a vertical asymptote on there, and then you just move that. It's pretty much wants to snap into place at x, whatever the whole numbers. The horizontal asymptote is always this extra number right here. So that's what we want. We want a horizontal asymptote of +2. And we got to reflect that. Only thing is how we're going to reflect that. Maybe we don't have to. I don't think we have to. So what we got to do, you need a little bit of algebra here. To find the x-intercept, you're setting y, let's say we write this as y, you're setting that as 0. Right? If you remember way back when, if you find the x-intercept, you set y equals 0. To find the y-intercept, you set x equal to 0. So we're going to find the x-intercept first, because that, this is the first one listed. So we're going to go 0 equals 2 minus 1 over x minus 3. So we go -2. This is the x-intercept. So we go -2 equals -1 over x minus 3. Then I'm going to multiply everything by x minus 3, or cross multiply, however you want to look at it. So we get -2x plus 6 equals -1. So then -2x equals -7. So x equals 7 over 2, which is 3.5. Now how do you graph a fraction on this? Like, it doesn't, again, you make your best bet. Like, it'll kind of snap into place, and it accommodates. Doesn't mean you'll find exactly 3.5. So 3.5, let's see. I gotta hide this. 3.5, that's our, so what you do is you click the x-intercept, and a dot appears. So we want to put the dot at like 3.5, around there. All right, that's the x-intercept. Now we want to find the y-intercept. So let's bring this back. So the y-intercept we'll do in blue. Now for the y-intercept, again, this is y. We're putting in 0 for x. So we get y equals 2 minus 1 over -3. So y equals 2 plus 1/3. Well, 2 1/3. That's 2 plus 1/3, so 2 1/3. So my y-intercept is at 2 1/3. So we click the y-intercept, bring it down to about 2 1/3. I don't know about there. And that's all we got. So then we just plot it. So again, this one doesn't have the stretching deal, but that should be it. And then you just submit it, and that's it. All right, so you saw like I wasn't like measuring to the thousandth yet. Yeah, did you make a pass? I wasn't measuring to the thousandth. You can go also. Measuring to the thousandth, but okay, it's still fine. I hope this is good. And rational equations. These I don't necessarily have to do, but whatever. We did ones like this, but I might as well include it anyway. So this definitely involves algebra. So we're just sweeping, basically multiplying the entire thing by the denominator, x plus 9. So we get -5 times x plus 9. On these guys, this, when you're going x plus 9, it cancels out. So you're left with plus x, same thing here. You multiply x plus 9, it cancels out. So equals -9. So we get -5x minus 45 plus x equals -9. So -4x equals 45 minus 9. So -4x equals 36. So x equals -9. Now again, you gotta plot this. Look, it's not gonna work. So this one, you gotta check for extraneous solutions, right? So now I gotta put that -9. I already see it's not gonna work. Whenever you get it in the denominator, it's a problem. So I'm putting this -9 in for x. Look at that. That's bad. All right, so you're getting basically -5 plus -9 over 0 equals -9 over 0. So that's false. So how do we put, the question is, how do we put no solution? All right. See what happens when I put it in there. There we go. No, that's deleting. X equals oh, I didn't see the rest of this. Still buckled. All right, let's try submitting nothing. Oh, there you go. You just submitted blank. You just leave it blank. Never seen them do that before. All right. And last one, direct variation proportion. I'm going to just show you one with proportion because I don't know if we saw ones like that. Maybe it's not going to show you. There we go. X and Y are in direct proportion. There's the same thing as direct variation. Y is 21 when X is 7. So that means it's basically Y over, Y1 over X1 equals Y2 over X2. You're just setting up a proportion with them in the matching place. So 21 over 7 equals, they want Y when X is 10. So you get 7Y equals 210. So Y equals 30. And that's it.